the reaction forces at A and B. And to do that, first thing you want to recognize is that this is a pin joint right here. So for a pin joint, you're going to have a reaction force in the x direction, labeled a sub x, and a reaction force in the y direction, a sub y. And you can orient these arrows either way. At the end, when you solve the equation, if it comes out negative, it's the opposite of what you guessed. So it doesn't matter which way. I labeled them to the right and up. And at B, this is a roller joint, so it's not going to have any reactive force in a horizontal direction. It'll just slide. So you know that this is directed straight up. Now, looking at this diagram, you have an unknown here, an unknown here, and an unknown here. To solve for, first thing you can do is solve for B, because you know if you make a moment equation, some of the moments about A, you don't have to worry about these two unknowns. They're not involved in it. So by making a moment, a little trick is you can eliminate two unknowns, or you can eliminate the unknowns at that point, which is why I chose to take the moment about A. So first would be the distance is 4 times 5,000 newtons. That's the perpendicular distance to the force, and it's negative since it's causing the body to rotate clockwise around A. Right here, this distance will be 6 times the cosine of 45. Cosine of 45. And another 2 plus 2. That'll be the distance, perpendicular distance, times the force, which is 10,000 newtons. And finally, that is equal, and you know what, this is actually negative as well, because it's causing the body to rotate clockwise. Negative. And B, we're going to say is positive, plus the distance here is, the perpendicular distance is 6 cosine of 45 plus 6 times B equals 0. Equals 0. And to get that distance, it was just 6 cosine of 45. That gave you this part, and then this is just another 6, and we multiplied it by B. Solving this for B, you can do it yourself, but you're going to end up with B equals 8,047 newtons. And so that gives you B. Now you need to solve for A sub x and A sub y. You can do that with some of the forces in the x direction. First off, it is A sub x, we got right here. And as you can see, this doesn't contribute anything and this doesn't contribute anything. So you're able to know right off the bat A sub x is going to be equal to a minus. So I guessed wrong here. It's going to be a minus. It's going to be the sign. Cosine of 45 times 5,000 newtons. So A sub x is going to be equal to 3,536 newtons. 536 newtons. And it'll be directed to the left. To get A sub y, you're going to take the forces in the y direction. So A sub y minus sine of 45, that's the y component of 5,000 newtons, multiplied by 5,000 newtons. And for this guy and this guy, you don't need to take components. That'll be minus 10,000 newtons minus 10,000 newtons, and then b is pointed upwards, so that's a positive b, which we just solved for, 8,047 newtons. So we're able to, and this is all set equal to 0 because it is a statics problem. We're able to solve for y, and then y is going to equal 5,489 newtons. 5,489 newtons. And that is how you solve a simple free body diagram like this. I think the hardest part is just making sure you get your distances right when you take the moment, because when you do the sum of forces in the x and y direction, you don't need to take the perpendicular distance times the force. It's just straight up the forces and the components of the forces in each direction. Anyway, that's how you solve it. Thanks for watching.